On number 29, they give us a picture of a rectangular box with a square base with a volume of 20 feet cubed. And they go on to tell us the cost of the material for the base, the sides, and the top. And they're wanting us to find a function of the variable x giving the cost of constructing the box. Now, to start this problem out, we want to identify what they are giving us. They tell us that the volume equals 20 feet cubed. So notice down on the board I have written out the equation for the volume, length times width times height. And in terms of our problem, volume is 20. Length is x, width is x, and height is y. So that tells us that 20 equals x squared y. And they also tell us the cost of the material in terms of feet squared. Anytime you see feet squared, they're giving you information about the area, which is the surface area of the box. I've listed as SA equals B plus 4S plus T. B is the area of the base, S is the area of each side, and T is the area of the top. And in terms of the cost, I'm writing C for cost. The base costs 30 cents per feet squared. The side is 10 cents per feet squared, and the top is 20 cents per feet squared. Now the area of the base is length times width, or x times x, which is x squared. The area of each side is length times width, which is xy. And the area for the top is x times x, or x squared. Okay, and at this point, I want to stop and realize that I need to find a function in terms of x. And so I've got this y right here that I need to write in terms of x. So I'm going to come back over to my volume equation, solve this for y by dividing x squared on both sides. And I get that y equals 20 divided by x squared. So I'm going to come back into my cost function and substitute in 0.4x times 20 over x squared. And then I can combine like terms. 0.3x squared plus 0.2x squared is 0.5x squared. 0.4 times 20 is 8. And an x can cancel, leaving us with 8 divided by x. And this would be our equation for the cost of constructing the box in terms of x.